With that, Chris Clark from the Whatcom Conservation District, engineer and dairy planner, and Derek Hunt from Agriculture and Agri-Food Canada, who is a crop specialist and so much more, will be talking about record keeping tools today. So I'll turn it over to them. Thanks.
Hello everyone. I've been working with nutrient management since 2000. Great to see Bass here. He was one of the original board members when I came to the Conservation District. I appreciate being able to work with everybody, or most of you at some time or another, most of you I know. The rulemaking change that the Washington Department of Agriculture put out in 2013 is affecting your nutrient management record, what they expect to see when they come to your farm. And many of you that I wrote a plan for 14 years ago, those things have changed, what they're looking for. So we want to identify what they are and the pieces of or tools you can use to get those records into place and be able to use them on your farm. I put some of these, they're 3-hole binder punched already, pamphlets from the Department of Agriculture up here, and I'm going to go briefly through that quickly, and then hopefully give Derek and his presentation enough time to get through that tool. The nutrient management changes, again, 5 years worth of records. They're expecting to see that on your farm when they come to your farm. That's one of the pieces, agronomic applications of manure. There was a lawsuit in Yakima. The federal judge held that they did not show or provide adequate records to show that they applied their manure agronomically, and that is a big deal right now. I'm sure everyone's heard of that, and so trying to help you be able to develop your records if you were in that kind of situation to show that you've utilized your manure in a way that is expected. The records to show that agronomic rate, it's to show that it's been put on to supply the crop for the proper growth, and that's not just going out there doing the same thing over and over again. We have tools that we put into place with the full nitrate test or the PSNT to use that we have identified in your plans, and we're expecting that you're using those. And the question is, are you making adjustments as you go to help reduce over-application of manure, but also in the cases where they're short, to apply the right amount of manure to get the yield that you're trying to get to. The penalty for not keeping records is up to $5,000 per calendar year. The first step through there, they'll give you a letter of correction, letter of warning. They'll start enforcing on that after a couple of years, but it's going to take time to actually get the amount of records they're looking for. We don't have all these pieces in place currently, but if you've been inspected lately, you know what they're looking for as well. The list on this, there's a long list and a lot of things that is, in my opinion, no one in the country's actually taken all these samples or everything they're asking for, put them into place, and calculated this out. So don't feel like you're not starting new, because we've done quite a few of these, but there are a lot of these extra little steps that we haven't had in place. The soil testing piece that they identified in the list is for the once every 3 year, the complete soil test. pH, phosphorus for our area is Bray P1, and that's because of our acidic soils. Potassium, organic matter. They put on their list both ammonia and EC, which is electrical conductivity. Those last two we don't usually have issues with in our area, and they are not enforcing not having those because we haven't tested for them, because in the high rainfall areas that we live in, we don't see that as an issue. We usually have low numbers. Where you see that being a bigger issue is in the irrigated agriculture, where they're getting a lot of evaporation and the salt builds up. They'll actually depress the nutrient removal by the crop. The other one on here, the two that at the bottom of this is the PSNT, the freeze-hydrous nitrate test for corn. If you're growing corn and want to do side dress, there's recommendations and some numbers inside your farm plan for trying to identify when the proper use of that extra nutrient is going to help increase your yield, or at least get to that yield goal. That's one that they've rarely regulated on, but it's something that the fall nitrate test has shown that there are oftentimes over applications, especially in the manure field, where we have mineralization timing issues with our cold soils, and then all of a sudden we get a spike or lack of nutrient being available. We put on a little bit more fertilizer and you could end up with an overshoot of the fertilizer needs. Again, the EC one is already talked. Manure transfer is something that we put these big papers in into your farm plan about manure transfer. How do you get rid of some of this manure, or export off to your farm if you have excess manure? It's a long legal document, your farm plan, and then we started making these manure agreements a little bit more defensible, I guess is the right word. The idea is, though, you have to do the agreements to get that manure calculated off of your farm, and who's responsible for that application is a big question right now. When you're applying it on your dairy, you're under Washington Department of Agriculture as your regulator. As soon as you export that off-site, it becomes Department of Ecology if it's going to a non-dairy, and there are others out there that are questioning some of the practices we're doing on that export piece, because there's no oversight typically on those non-dairy facilities, especially in other areas of the state, but even in our area where it goes to a raspberry or a crop field and there's no nutrient tracking of that. The Irrigation Records is a new one on this list of rulemaking. They're, again, not pushing this one so much here in Western Washington because of our high rainfall. It's not as important. For the process, though, of writing your farm plan, many of the fields that we associate with high yields have irrigation needs on them. And a lot of our fields, we want those records in place because it helps identify that you've done the right management, and so that we can account for that nutrient in that calculation. Manure samples, something that you're supposed to do annually, is on the rule with a laboratory sample. That one in your farm plan, we've written it in as we would like to see that 3 times a year with the different seasons we have, different amounts of nitrogen, or actually amounts of rainwater in the in the lagoon. That changes that amount that's going on in the field. The annual sample that they've identified, they want to see the organic nitrogen, ammonium nitrogen, and phosphorus. In our farm plans, we wrote total nitrogen, ammonium nitrogen, phosphorus, and potassium. The potassium one isn't so much a water quality issue, so they've left that one off. Organic nitrogen is actually total nitrogen minus ammonium nitrogen. So again, there's some of these pieces that as a farmer you're not going to be used to seeing some of these numbers, and some lab samples might say nitrogen, some might say total nitrogen. Kildall nitrogen is another name, but you're not going to see organic nitrogen on your lab sample. So the question is, what do I put down for my record to make the Department of Agriculture happy? And understand that there are some things that are changing in this system. The old way, I've got some of the record-keeping field books, putting down application dates, what kind of manure. It did record keeping. We put down records of how much manure went out there, and it didn't do the extra step of calculating how much to show agronomic applications, and that's the step that needs to be worked on, and that's the piece where we're hoping to get to a little bit later on. The application of nutrients, so the totals of those applications, when you put on total nitrogen, ammonia, phosphorus, adding those up, having that record on hand, So when they inspect, they can see those numbers. The available from each source, that's where we get into some really different numbers coming out of different research or resources if we're looking at trying to identify how much is actually available from the plant. The total organic or the total nitrogen that's been applied in this case was 479 pounds. The ammoniacal nitrogen was 293 pounds. The calculation we use within your farm plan would say that available plant was 242 pounds. And in this example, it's coming up short on the -7, but the 120 pounds coming out of organic matter in your soil is a piece of this that we're, again, looking at your organic matter from your soil test and developing these numbers around book values. And so trying to understand, are you going to go to this detail to get this information, or you're going to leave it to your consultant to do this, but having an idea that they're going to come back in and say where'd that number come from if you don't have a good reason. Some of these numbers may have higher losses during the summer from volatilization. Some of them might have higher losses for denitrification if you're applying in the wet soil situation. The farm plan again looks like this. These numbers for losses come out of these tables. If you're trying to do this on your own, on your piece of paper such as this, it's going to be difficult to come up with the calculations, but you can do it. It's in the literature in the plan. The application loss figures on method of application, there's again book values on those. The nutrient needs or crop needs based on yield. Yield is something that we haven't pushed for in the farm plan as a requirement. In this rulemaking, it's put in here that they're wanting to see that. That's a big step for where we're at. We need moisture, we need proteins, we need to get to a dry matter yield to determine how much you are removing, and that's going to be a challenge for producers. But it may help quite a bit if you have a low yielding field. Is there a reason for it? But how much manure have you put on, and is it correlating with some of the soil test numbers? Is there advantages to putting on something like lime to help change some of the nutrient uptake requirements? Is there pieces that will, if you're actually harvesting more yield, maybe those numbers should be moved up in your farm plan to adjust for that. The big pieces with totals, again, adding those up and coming up with what is being removed for the crop year. Another additional piece is weather conditions, and they want to know what the weather conditions are 24 hours prior to applying manure and during that application. They had an example on this piece of paper, pretty simple, but it doesn't even meet their own requirements of what does that show or what. So I think that the expectation right now is simple, trying to get people to do it, but there is some other tools out there to help with that. And the Conservation District, Nicole worked on the manure spraying advisory. I know this is really small, but I hope everyone that's seen this number of times, they understand what it can do for you. On our web page, you can click on your area and it'll bring up the weather forecast. The idea that you're going to go to these kind of sites to determine if you're going to have inclement weather before you apply is a big piece of not having runoff. If we have a ½ inch of rain and it's the middle of July, there are times when that may be appropriate to go ahead and apply that manure, but you need to know your field conditions as well as that rain. But the rainfall, you need to record that, so when there is a runoff event and it's outside of the prediction, that will help you cover some of the questions of why did you apply on that date. The piece of how do you get that into your records? So in Microsoft, in the computer systems, you can use a clip tool that will actually clip out that exact weather data that you just pulled up and put it right onto your desktop or onto a spreadsheet. That's one way to do it. You've got all the information that they're asking for the 24 hours before. We have our these weather data points you can add up, or we've already done it for you in the manure spreading advisory. Flood watches, we've got a number of different tools on the flood watch side with USGS and the NOAA stuff that helps identify when floods are coming, and it's not a long-term predictor, but how high the river is going to come. And so those pieces are out there, and understanding how that gauge at Ferndale or at Nugent's Corner affects your fields is useful information to know how fast you need to get out of the way or stay away from a particular field. Irrigation schedulers, one of the things that I've worked with a little bit, we had Troy Peters from WSU explain it training, but the tool that I've used with it is identifying the water holding capacity of a soil and having it show, you dial it into the number that you want to have your soil dry down to before you time to apply manure. In this case, this is today, and this one's developed around the 85% water holding capacity that is in some of the ARM worksheets. So understanding that we had a soil that when the blue line hits it, it's saturated and there's runoff happening. When it goes below it, there's times when it goes below it, there's times when it catches back up. And so this last week, we got a dry period, and now we're below it. And this difference right here is about a ½ inch. The ½ inch is about 12,000 gallons worth of manure that you could apply before it would run off. This tool is something I think, again, coming into this weather forecasting that we're going to be required to do is going to be important. The irrigation scheduler is developed around irrigation needs, though, so it's trying to send you a message when you have to irrigate. And so at this point, when I dialed it in at my 85%, it sent me an email today saying, we're in a situation when your soil is too dry, you need to irrigate. So that email is going to come up and say, you know, your manure, your fields are dry enough that it's appropriate to irrigate on that field. The tool, again, is trying to base some of this science, but also the weather station data that's out there. And WSU does have a number of these weather stations that they've put together. They have 4 in the county, and you're able to get some of this information by bringing all this information in together at the end of the year. You can actually use the same exact tool. You can add your irrigations. So the green dots are irrigations. The green dots down here are irrigations, but using them to mark when manure is applied. So these manure applications I put in on this example was for last year at 10,000 gallons an acre. This was 1.5 inch gross irrigation. But that gives you your record. When you applied, how was the weather? There's the weather. That's the annual weather. These squiggly lines are actually cutting times. So it kicks the irrigation scheduler into a different evapotranspiration number. To get the weather data, the longhand way, you can go to these same weather stations. You can pull out your weather station in your vicinity. You can put in the whole year, and you can download the entire weather for the year for that weather record. That'll get you your weather record for after you've applied. You can go back and highlight when you were applying. That meets that record requirement for manure application weather reporting. Next piece I'm going to let Derek talk about, but Farm West has been a weather station. They have a number of different pieces on it, from the T-sum calculator, the ammonia, the loss numbers. There's a calculator on there for that. There's growing degree days. It's been a very useful tool for Ag Canada that we've used and had success on that. The NLOS model itself is a, I'll let Derek explain a little bit more, but I've actually used it. This is real data, and we can get to showing what is going on in the soil with this model. The question on nitrogen leaching, when they're talking about how much is leaching out of your soil, but how do you actually dial things back or add irrigation water or nutrients when it's needed to add to your crop system. Okay. Is there any questions real quick? Everyone going to sleep?
Okay, I'd like to thank Chris and Nicole for inviting me down here for this talk. My name is Derek Hunt. I've worked for Agriculture Canada, what was called the research branch in Agassiz, BC for almost 27 years. Shabtai, who's also here today, and he'll answer any difficult questions. I've worked with Shabtai all that time, and with Chris with this NLOS model. So this is a tool for managing nitrogen, and it looks at all the complexities of the soil, and it's a work in progress. So we're constantly trying to update it and improve the usability of it, and also to get people participating in improving that. So just to briefly start off, NLOS it's a soil, plant, water, nitrogen simulation model. So it's completely run on the computer, run with source code, and it derived from the USDA's NE model that was developed by Marv Schaefer in the late 80s, early 90s in Fort Collins. And this would be, if you had a computer 25 years ago, this thing would run on it and would run extremely slow, and you'd have the old-fashioned types of interfaces. So what I did with that is I took that interface out of the source, that old interface, got rid of it, took all of his calculations and computations, and put them into a kind of more modern platform, which is called Stella, which is a commercial piece of software that comes out of the east coast of the US, I think in New Hampshire. And it's not necessarily for agriculture, but it provides the environment like Microsoft, Excel, and Windows provide the environment for you guys to do work in. This program called Stella allows me to graphically design a computer model in an environment. So I manually took that source code, which was, you may have heard of Fortran. Still a lot of stuff is written in Fortran, and it's all it's in the background. You don't see it anymore, but they've built more and more interfaces on top of it. I kept the original algorithms. In this Stella platform, I can add and change the model. And a problem with a lot of these computer models in the past, the research models, the expert system models, is they were called what I call black boxes. So you didn't know what went on inside the box. You fed information in, and stuff came out, and it either made sense or didn't make sense, but you never knew why, because the person who programmed it had it all locked up in a black box, and usually the code was proprietary. You can't see Microsoft's code, and you just need it to work. But with these computer models, they're simulating various things, fish populations, animal populations, agricultural situations, and you don't know what drives them. So with the Stella platform, we could kind of unpack the box. Marv gave me the source code for free, and we can put it where it's available for people to look at and check, criticize, improve, whatever's necessary. So on this platform, we can add, output anything in the model. It's open source, which is popular now on websites. It's called open source software. It runs on a daily time step, and this is a kind of an industry type of thing here, where we can take this onto the web, and it can integrate with other computer models built in other systems and platforms. So NLOS, as I mentioned, is a computer simulation that simulates the soil processes. So what it looks at is crop uptake, runoff losses, leaching, volatilization, which Chris mentioned, and nitrification, denitrification, mineralization, and mobilization. And what are all these terms? These are things that are happening in the soil, and they're the processes that affect your soil nitrogen. Crop uptake, you're all familiar with this. You can look at this is a crop of alfalfa we're growing in Agassiz, and you know the value of that crop and is affected by the nitrogen which that plant produces itself. It's the nitrogen that gives that the quality, and that it turns into feed protein. With corn, the nitrogen affects the growth and yield of that crop, And it can also affect the grain set too. So with good nutrition, you get good grain set, good grain content in your feed. Runoff losses, they're invisible, but you can see them moving with water. So if you have some surface runoff, you could be losing that nitrate or the nitrogen in the form of nitrate to that surface runoff. And it is measurable in nitrate in surface runoff and in groundwater. And that's what Chris was mentioning in the people that are checking these water systems coming off of the farms. Volatilization, it's invisible. You may be able to associate with odor. If you can smell a lot of manure, you've likely got some ammonia in it. You just don't know what it is. It's a form of losing the nitrogen. It's very difficult to measure. We can attest to this at the research station. This is Shabtai's ammonia volatilization measurement system. No one else, I think we're the only ones in Western Canada doing this, and probably in Western US. There's very few people do it, and it's very difficult to measure ammonia. It's strictly kind of a research way of doing things, but we can come up with numbers, and we can predict volatilization, and then we can incorporate our predictions into computer models. So when Chris mentioned the Farm West, there's an ammonia calculator on there, which is using information that comes from these types of research studies to put on a website so you can use it as a tool. And the NLOS model incorporates this sort of information within it to estimate and predict volatilization losses. These things here, nitrification, denitrification, mineralization, and immobilization, they're invisible, they're completely invisible, extremely difficult to measure. It's mostly microbially driven, and these are the things that will affect how the nitrogen is lost from the system, how much of it may be tied up in organic matter, like if there's a lot of sawdust added in a product, it would immobilize that nitrogen. The mineralization is what is naturally released from the soil through to mostly microbial processes from soil organic matter, and that then becomes available to the crop. And when you apply manures, Chris mentioned the difference between the ammonia portion, that's immediately available to the crop, to the corn or the grass, and the organic portion. So the organic matter in your manure mineralizes. It changes from an organic form to an ammonia form, and it becomes available for the crop. So it's, I think with you guys, you call this a nitrogen credit based on your soil types. So this mineralization process affects your nitrogen credit that would be applied to a certain type of farm with certain field history or certain organic matter. Nitrification is a process that's inside the soil. It just turns it from the ammonia form to the nitrate form, and in this you can get things come off like greenhouse gases, like nitrous oxide. So you hear all this stuff about global warming, climate change, and that's being attributed to certain forms, carbon dioxide, methane, but also nitrification does produce greenhouse gases. And denitrification is what occurs in the winter to mostly wintertime from heavier moisture conditions. And that's the turning of your nitrate that you possibly paid money for to put on your field. It turns it back out into straight N2 gas, and that's lost from the system. So what NLOS does, it's a computer system, and it helps you visualize these processes that you really can't see, and it visualizes them daily and over the entire year, and it gives numbers for these, so you can kind of assess what the situation is in the soil and get some idea of leach-in losses or mineralization. And I say it's kind of a visualization tool, and it's analogous to a microscope or an X-ray or telescope. It allows you, a microscope allows you to see certain things at certain times. It's not everything. Same with a telescope. You can see things far away. And X-rays, none of them are perfect in the way to see everything, but they allow you to understand and visualize other things that we can't normally see with our senses. So how it does it, it's computer software, and I lay it out graphically. And actually in the Portland school system, they use this same software, and they're probably the best I'd say in the world in the school system for incorporating this Stella software into schools, and it helps people understand systems. And they use it a lot commercially. A lot of businesses will use this software to lay out how their business is run. If they have a production line and they want to know, should we run a night shift and a day shift, or should we build a second production line, they create it in these sorts of graphical representations, and then they know how long it takes their employees to make so many shoes. And they can then evaluate this in a simulated way, whether they should build a production line, they know the cost, or whether they should run a night shift. So it is used extensively within businesses, but for agriculture, I would say it's used a lot, but you wouldn't see a lot of it around. It's more like a research type event. So I create this, I sketch it out, how I think the system will be connected, how the plant is connected to the soil nitrate, how manure is applied to the field, how these microbial processes are going on. And then I enter equations and numbers into each of these little boxes. So if you're not a programmer, this type of software really helps because it looks after all the bookkeeping. If you've got 10,000 lines of computer code, there's probably only 200 lines of equations. The rest of it is all bookkeeping to look after the numbers. So, but it leads to a lot of complexity. So this is just a one-page shot of maybe 300 pages. So if I splash all that computer code out onto a page, it would probably cover half of the wall up there of 8.5 by 11 inch pieces of paper. So it's, in terms of this complexity, for people that want to know about, from a research point of view, how this thing runs, we can go through all of this, double-click on any of these, and we can see what equations are running it. And we can debate them, we can improve them, we can delete them, we can expand upon them. So to get rid of some of that complexity, what we do is we build an interface for it. So this is an interface where you can navigate to places, put management information, soil data, climate data. Then you can look at outputs where you expect an annual nitrogen budget to be. This one I had for grass growth, well, that's a picture of corn, but it's the same one I use for corn growth. What drives the model 100% is weather data. So we used 4 pieces of weather data, and this is extracted from Farm West, and you can also extract it from personal sites or from other data sources, or upload your own data. So it's driven by rainfall, the ET, which is the evapotranspiration, and the minimum and maximum temperatures. That's as simple as you can make it as something that will drive a computer model. And then you can visualize what's happening to the nitrogen in the soil. So this is a manure application. If it would be applied to, I think yesterday this would be February the 18th. At a certain rate, this is the amount of mineral or ammonia and nitrogen that appears in the soil. It's just a single shot of that manure to the surface of the soil. And then you could look at what happens to that application was put in here, and it is in mineral form, so it's ammonia. And then it takes time, because the soil is cooler, it takes time for that ammonia to turn into nitrate and then manifest itself in the soil in different places. So in the top foot of your soil, this is what it's predicted in terms of 100, I don't know what that is, about 180 pounds of, this is in actually pounds, US model is in pounds per acre, so this is in pounds per acre. Our website is has metric as well. So you can follow this through the season, where it's being really coming into the soil from the manure source. This is mostly crop uptake. This is a little bit of mineralization at the end of the season. And this is the heavy rainfalls that hit in the fall. And it just knocks that off out of the top foot. It comes into the second foot here, and it's gradually leached out through the soil. And this is the nitrate in below the 2-foot zone. So this would be what would be considered, if there's a, the corn crop is basically gone around here, and this is the soil, in this scenario, the amount that's left in the top foot. If you have a relay crop or a winter annual crop, it could capture some of this before the rainfalls take it out, or a deeper rooted crop can get it into the second soil zone, but it's mostly lost. So that's those big flushes of fall rains in this climate that cause the nitrate to be lost from the soil. I mentioned the mineralization. This is like the nitrogen credit you get from your natural soil organic matter. So given this is about a 7% organic matter, and the model is predicting that you're going to get over the season about 120 pounds per acre of nitrogen released from your soil. That doesn't necessarily come in the early part of the season because it's cooler. When the microbes are mineralizing that nitrogen. It's later in the growing season it becomes available, and then this is just a plateau because it's a cumulative, so I'm just summing it all up, what you're getting for the season. And you can look at different effects of this. So I ran different weather situations. So I had a dry May, June. It leaves the nitrate within the root zone. It's in with the rooting depth, and this is the nitrate here. And if you have a really wet May, June, that can move that nitrate below the root zone, and this has implications for side dressing. Like, you could look at that corn and say, it looks a bit yellow, should I side dress or should I not? And that's why you sometimes have the in-season soil nitrate test to determine whether you should apply or not apply. And what the model allows you to do is it predicts, and it's not too bad in terms of the relative amounts of it, where that nitrogen could possibly be based on the weather that you've seen so far. So you can use it as an extra piece of information, like it's all below the root zone, the crop isn't going to get it in time, so I should side dress, or it's only 6 inches to a foot down, and the crop will get it and it will pick up, and I don't need to side dress. So this is a farm, this is Mike Dykson's place, just across the border at Sumas there. So we measured in the field extensively what was going on in his field through the year. And if you're wondering how the model predicts what's going on, that's what all these little red circles are, is our soil tests. We were sampling weekly. Sometimes if the manure fertilizer was just applied, we'd sample twice a week, run that sample through the lab, and these are the types of numbers we're getting calculated from the ppm soil test of nitrate, and we're turning that into, here I've gone back to metric, sorry. That's the story of Canada, where it's never fully converted to metric. We're kind of a cross between metric and pounds and feet and things like that. So I'm the same way. I flip back and forth and don't know what I'm doing. So I've got this in kilos per hectare, and that's about 10% more than pounds per acre. So it's the model is predicting this black line, and this is not too bad. This is what we're measuring in the field with all the red ones. And this goes into the second season, and again, the little red dots are not that far off of what the model predicts. And then I just ran a scenario. If we apply fertilizer or manure here, the model is predicting this green line. If we then fall apply manure here, this is what we would expect from the model in terms of the nitrate levels that we'd see in the soil from a late season applied. So it's just a way to look at possible scenarios. So what I described mostly so far is actually on the PC. And you could use that. You need to pay for software to run it. And what we want to do is we want to make it freely available. So we've taken our NLOS model and we put it on the web. And this is what you're getting. You're under growing pressure to increase more crop and have like 0 environmental footprint. So there's tools available as management tools you can use. The soil tissue testing to determine when you can apply nitrogen. There's a lot of stuff recently, especially with drones, all of this spatial management data. Everyone can fly over the cornfields with their drone and take these scans and evaluate what's the nutrient status of that corn crop. And can they then use that to predict how much nitrogen you should apply and possibly when. That's the same thing as like a remote sensing tool, but that's more of a higher elevation. There's lots of delayed release nutrients. So we use, at the research station, we've investigated different types of slow release nutrients with inhibitors or coatings, and there's lots of products available that help you put nitrogen on maybe one application and then make it available slowly over time, so you don't get the losses and the crop can benefit from it. And in-season nutrient application, so that's the side dressing. So, but in addition to these sorts of physical things, we feel that these modeling tools can be used as an extra set of tools, so you can visualize the complex processes, like when I mentioned the mineralization, denitrification, You can visualize those with a computer tool. But you need, and you can track and predict possibly these complex processes. So what we've done, NLOS is on the web. It's freely available. You can run it in real time with real-time weather data. As I mentioned when I started off the talk, it's evolving. So we're trying to improve it. It's data hungry. So we're trying to put up scenarios so that you can pick a scenario and get running with a scenario. And if you have your own farm data, or if consultants or guys like Chris have data, they can give you data to include into these types of models. And I mean, there's some unique aspects of it, is we can couple the real-time on-farm weather data with soil temperature and soil moisture. And this is stuff that's evolving, and we've got it in progress. So we're trying to add these capabilities all the time. And you can enter your own specific soil and management information, and you can game with it. And you can make up scenarios. So none of this information, it's on the website, but no one knows if this information is real or if it's just imaginary. So you can put in field scenarios, and you can say, what if I do application at this time? What if I do an application at a later time? And then we have done some, like I mentioned, that farm at Mike Darshorn's, we've done some on-farm testing to see if we can calibrate that for his farm and see if we can do changes. And I mentioned the what-if scenarios. So this is a screen. I've got the model on the computer here, live, I think, if I don't have to log back in. But these are just screenshots of the website where you can create this. You just create your own graphs of what you want to see. So in this case, I just picked soil nitrate in the top layer at Agassiz. The greenhouse gas people are really interested in what's happening with greenhouse gas emissions, so we're tracking what's happening with greenhouse gas emissions. New Zealand likes to produce and export what they call green milk. It's milk that's produced in an environmentally sustainable way, so they're really intent on cutting down their greenhouse gas emissions. So they've done a lot of work on nitrous oxide. So we have had interest from the dairy farms of Canada in what's happening with nitrous oxide. Can we come up with techniques to reduce that, and then it kind of environmentally greens the production of the milk? And we've done a lot of work at Agassiz in measuring greenhouse gases from the different manure application and production systems we're using. That's the inputs that can be used. So in here it just shows pick a dairy manure, liquid broadcast to the surface, a date, amount, a gain in kilos. And this is what it's applying based on the characteristics of that manure. And this is just another screenshot of the how you can pick different multiple applications of fertilizer, and you can design your own custom blends. And this, we do have a tab on there that is like a web app, a phone app. So you can go on there and run what's called a quick summary. So it's predicting how much mineral or ammonia is left in the surface and in layer 1, how much nitrate is left through the soil profile. The water-filled pore space, that's at the end of the season, but that relates back to Chris's comment about the irrigation schedule. That water-filled pore space is the amount of room that's left in that soil to add more water, or as Chris mentioned, the amounts of manure. This is what's leached, volatilized. I've done cover that one up. And then these other soil processes I mentioned, like the denitrification and the mineralization, it sums those up. But these are things that we can change on the interface. You can either have them or not have them. These are the ones we were interested in. So I just did 2 management scenarios. There's a February 18th application and a May 1 application. I was just comparing the two side by side. And what we've got what we're trying to develop for this web application is to develop upfront scenarios. So the model is data hungry. You need all the soil information, detail of the manure content, the manure type, and the manure characteristics. So if we could come up with, and the hardest one for us in Canada is to get the soil information. I think the US is way ahead of us in making the soil information available for people to access. It's really difficult for us to get it. So it's so this is like one scenario. I've got some of them here. This doesn't actually work yet, but it's one of the things we're trying to plan to add to the NLOS website. It's where you pick it's a corn silage system. You pick that system, you can apply your manure or fertilizer, tillage, and manure applications. And I talked to Chris about this, and he wants to see the manure characteristics in pounds per 1,000 gallons. So I've got that on there. There's always this difficulty with units and conversions and stuff. So I'll just see if I can bring up the web one. I might have timed out on this, so that's the two, I called it Agassiz Corn 3 and Agassiz Corn 4. I had those two little summaries side by side. And you could run these, and you can pick what graph you want, and you can pick how you want them to look on the screen. So it's called a dashboard. So dashboards are popular in business, and this is our version of a dashboard. And, oops. Does the mouse work? Oh, you're saying it has problems on the table, right? Mm-hmm. Yeah, okay. So if I mouse over this graph, this is the, it just says tells you on day 175 of the year, you've got 134 pounds per acre of nitrate in the soil. That was the one scenario. And then you hover over this one, and it's got 148. And I think if at the moment, you can run a scenario and it gives you the results, but what we'd like to have is you can run field A, field B, and compare them side by side. So I don't have that capability built into it yet, but what I've done is I've just logged on as 2 usernames and 2 passwords and got them running side by side. And that's why we've got a Internet Explorer and a Firefox browser running. And this is all built, the whole website is built with free software. So we have to be able to build it on the cheap, and we have to have it modifiable. So it's all free available software that's out there. And one's called Safari. And we have a guy who works with us who actually takes what we give him in terms of the computer model, and we give him all the layout and look of it, and then he puts it into the web interface for us. So it's a bit on the cheap. It doesn't look as glossy as most websites, but it is free, and it's free to use. So this is just an example of this dashboard I did here. So the water filled pore space there. Oh, I think I've given that one the wrong title. I did this late last night because I wasn't ready. So that should be the nitrous oxide title right there. But here's the water filled pore space through the year. And these little bumps here, on this here, is what Chris was mentioning about when you've got availability. This is up to yesterday. So here are these little windows where you would have ability to apply manure. So that's when rain event dries out, and we've got them constantly going. And this is the dry down right into the summer, where we're going into water deficit. And then earlier when someone came in, they mentioned, did we get that 2-inch rainfall in July? I forget you mentioned that. And we did, and that's kind of what saved our corn crop this past year, because we didn't get into moisture deficiency. And here's the ammonia emissions. So it's about 28 pounds per acre of nitrogen on that day. It's predicting it's lost. So if you look on the FarmWest website, it has the ammonia emissions calculated there, and you can look that up and you can get an estimate of what you think you would be losing. And then this model predicts the same sorts of things here. And then there's the mineralization here.